Welcome to a slow, beginner-friendly lesson on why testing matters in Python, made for absolute beginners. The case for tests. Today we answer a question that every developer asks sooner or later: why should I write tests? Writing code without tests feels fast, you just run it and see if it works. But that speed is an illusion. In this lesson we slow down and look at what testing really means, what happens when you do not test, and what a single test looks like in Python. No frameworks yet. Just the why. Why bother at all? Here is the project layout we will use. Source code lives under src, in a file called calculator.py. Right next to it sits a folder called tests, with a file called test_calculator.py. That naming is not accidental. Test files start with test_ so test runners can find them. Hold this idea: production code and test code live side by side in the same project, each in its own folder. Source beside tests. Set up the project with uv in it, then add pytest as a development dependency using uv add --dev. Notice the --dev flag. Pytest is something you need while writing code, not while running the finished app, so it belongs in the dev group. uv records this in pyproject.toml under dependency-groups. Your end users never install pytest, only developers do. Pytest in the dev group. Running tests is one command, uv run pytest. With no arguments, it discovers every file named test_something and runs every function named test_something inside them. You can also pass a single file to focus on one area. Add -v for verbose output, which lists each test by name. That is the entire day-to-day loop. Write a test, save the file, run uv run pytest. One command, run often. Every test starts with a question: how do I know this works? The question that starts it: what is a test, really? A test is a small piece of code whose only job is to check that another piece of code behaves the way you expect. You write the test once. Then a tool, like pytest, runs it automatically, every time you change anything. The test calls your code, compares the actual result to the expected result, and either passes silently or fails loudly. Think of it as a tireless assistant that rechecks your work forever, for free. Code that checks code. Here is the smallest possible test. In calculator.py we define a function add that returns the sum of two numbers. In test_calculator.py we import that function and write a function called test_add two numbers. Inside, we call add with 2 and 3, store the result, and assert that the result equals 5. Assert is a Python keyword. If the comparison is true, nothing happens. If false, it raises an error. That error is what pytest reports as a failure. 5 lines, full power. Without tests, every change is a small act of faith. With tests, every change is a small act of proof. Faith is not proof. Picture the workflow without tests. You write a feature. You run the app once, click around, and convince yourself it kind of works. You ship it. Weeks later you change something unrelated, and quietly break the original feature. You do not notice, because you stopped checking it. The customer notices instead. Every change becomes a gamble, and over time fear creeps in. You stop touching old code because you do not know what it might break. Slow decay. Without tests, your only safety net is running the app and looking at the output. Result 5, looks right, ship it. But what about negative numbers? What about 0? What about very large numbers? You cannot keep all of that in your head, and you definitely cannot rerun every check by hand after every change. Manual checking feels fast the first time. After the 50th change, it is unbearably slow, and human brains are bad at it. So you skip it. That is when bugs escape. Manual does not scale. Confidence is not a feeling. It is a green bar that appears in under a second. Confidence is a green bar. Now picture the workflow with tests. You write a feature. You also write a test that proves it works. Every time you change anything in the project, you run uv run pytest, and within seconds every test reruns automatically. If you broke something, a test turns red and tells you exactly which check failed. You fix it before anyone else sees the bug. Old code stops being scary, because the tests catch breakage instantly, every single time. The fast loop. Here is what running tests actually looks like. uv run pytest collects the test, runs it, and prints a single dot for each test that passes. 100% at the end means every test passed. The whole thing takes 0.02 of a second. Imagine doing that by hand. You cannot. That speed is the whole point. You can run 1,000 checks in the time it takes to drink a sip of coffee. Milliseconds, every time. Why does this matter so much? Because tests buy you confidence. Confidence to refactor. Confidence to add features. Confidence to upgrade dependencies. When you have a test suite, you can change code aggressively, because the tests will tell you the moment you break something. Without tests, every change is a gamble. With tests, shipping becomes almost boring, and boring is exactly what you want when you ship software. Buy courage. A regression is the quiet killer of trusted software. Tests are how you fight back. Fight regressions. There is a word for the most painful kind of bug: regression. A regression is a feature that used to work and then stopped working, usually because you changed something elsewhere in the codebase. Regressions are sneaky. You did not touch the login flow, but somehow login broke. Without tests, you find out from a customer at 3 in the morning. With tests, you find out the moment you run them, before the code ever leaves your machine. Used to work, now broken. Here is a regression in action. Someone refactors add and accidentally turns the plus into a minus. Maybe they were tired. Without tests, this ships, and users start getting wrong answers. With tests, the assertion fails immediately: expected 5, got 3. PyTest points you at the exact file and line. The bug never leaves your machine. That 5-line test just saved you a customer support ticket. A typo, caught. There is a hard economic truth in software: the later you find a bug, the more it costs. A failing test in development costs you 5 seconds. A bug caught in code review costs minutes. A bug caught in staging costs hours. A bug caught by a customer in production costs days, lost trust, lost sleep, lost revenue. Tests push bug discovery as early as it can possibly go, into the moment you write the code. That is the cheapest place to fix them. Earlier is cheaper. You now understand why testing matters. The rest of the journey is learning how to test well. The road ahead. When should you write tests? The honest answer: test anything that matters. Business logic, the rules that make your app correct, deserves tests. Edge cases, empty lists, 0, negative numbers, very large inputs, deserve tests. The happy path, where everything goes right, deserves a test. But you do not need to test every line. Trivial glue code may not need a test at all. Aim for the parts where breakage would hurt. Test what matters. What makes a test good? 4 things. Fast, tests should run in milliseconds, so you can run them constantly without thinking. Independent, one test should not depend on another, each must work alone. Clear, when a test fails, the failure message should tell you what went wrong without investigation. Focused, a single test should check one behavior. If a test does 5 things, you do not know which one broke. These 4 rules take a lifetime to master, but they are the entire craft. 4 properties. Here is a slightly bigger test file to give you a taste of what is coming. 2 tests in one file. One checks normal addition, one checks negative numbers. Each function does one assert. Each runs in isolation. We go deep on PyTest in the next lesson: how to write these, how to run them, how to read the output, and how to find the cause when one fails. For now, just see the shape: small functions, clear asserts, no surprises. Small functions, clear asserts, quick self-check. Can you explain what a test is in one sentence? Can you describe what happens to a project without tests over 6 months? Can you define the word regression? Can you say why bugs found early are cheaper than bugs found late? If any feels shaky, rewind the matching section. You do not need to write a test yet, that comes next. For now, you just need to be convinced that testing matters. Say each out loud. Here is the lesson in one breath. Tests buy you the confidence to change your code without fear. They catch regressions, features that used to work and quietly broke, automatically, every time you save a file. They push bug discovery from expensive, customer-facing moments to cheap, developer-facing moments. Manual checking does not scale. Automated tests do. That is the whole argument. Confidence, regressions, cost. Next we get hands-on. We install PyTest, write our first test functions, run them with UV run PyTest, and learn how to read the output when something fails. By the end of the next lesson you will have written your first real test and watched it pass. Then we go further: fixtures for setup, mocking for external services, and finally packaging your script so others can install it. Hands-on next. Thanks for understanding why testing matters. Next we write our first tests with PyTest. The case is made.